Section 6.5, operations with radical expressions. This is really similar to the last section where we had nth roots. Now we're just going to be performing operations such as adding them together, multiplying them, etc. So here we have the square root of 8x to the fifth. We know how to do this one already. We're going to break down this 8 with a factor tree, 4 and 2. The 4 breaks down further to the 2 and 2. And we want to take out any pairs of numbers. So we have a pair of 2's here that's going to move to the outside. And then this 2 is left over. He's going to stay on the inside. We have 5 x's. Any pair of x's is going to move to the outside. So these x's are going to make 2 on the outside because we have 2 pairs with this left over. Okay, so everything on the outside is this 2, okay, and then these 2 x's, 2x squared. All right, all these green highlighted things are on the inside, so a 2 is on the inside along with that x, so we have radical 2x, and that's our answer. Here we have a cube root, same idea, except now we're looking for 3 of the same things. Okay, we're going to break down this 24. 6 and 4, 3, 2, 2, 2. Okay, so the difference between this section and last section is last section everything moved outside, and this section we have something left over. Okay, that 3 is left over. Okay, when we look at this A, for example, how many groups of 3 are in a to the 14th? Okay, there's 4 groups, but there's still 2 left over because 3 goes into 14 4 times, but that only takes up 12 of the A's, okay, with 2 remaining. B's, on the other hand, it goes into evenly. There's 6 groups of 3 with none left over. All right, so when we write it out, we have a 2 on the outside because there's 3 of them. Okay, we have 4 groups of 3A's, so A to the 4th. 6 groups of 3B's, B to the 6th. But in the inside, there's still a few things left over. So you have the cube root of 3A squared. Number 3, 3x to the 2/3 power minus 5 cube root of x squared. First thing to note here is that if we were to rewrite this expression here, this cube root of x squared, as a fractional exponent, okay, the root is always going to go on the bottom, right? So this is really x squared to the 1/3 power. Okay, and now we could multiply these exponents, and we would get x to the 2/3 power. So really both of these are the same. They're like terms. They're both x to the 2/3 power. So since we have 3x to the 2/3 power minus 5x to the 2/3 power, all we're going to do is subtract the coefficients. 3 minus 5 is negative 2x to the 2/3. You can write it like that, or you could write it as a root, negative 2 cube root of x squared. Everything we've learned about radicals is still true, namely that we're not allowed to have a square root on the bottom. So if we have the square root of 4 over x to the 13th, okay, and we split it up like this, radical 4 over radical x to the 13th, and we simplify both of them. So we have a 2 on the top. There's 6 groups of 2 in the bottom here, okay, with 1 left over. Right? This is not allowed, which means we need to simplify it, we need to rationalize it, and we're going to do that by multiplying the top and the bottom by that radical x. That's going to give us another x on the bottom. That's going to combine with this x to the 6 over here. So now on the bottom we have x to the 7th, and on the top we have 2 radical x. So with that in mind, let's split up number 5, top and bottom. Okay, and we want to simplify both the numerator and denominator as much as we can. So let's start with the bottom, split up that 16 to 4 and 4, and then to 4 2's. Okay, so we're looking for a group of 3, and we can take out 1, 2 with this extra 2 left over on the inside. We can't take out any y's because we don't have at least 3 y's. On the top, we have 9 x's. We want groups of 3, which means we can take out 3 groups of 3x's with none left over. So simplified, we have x cubed that came from these 9 x's here. This 5 just stays on the inside. We can't break that down. A 2 came to the outside. We have 1, 2 left over, and those y's left over. Now, this is not allowed on the bottom. Okay, we need to rationalize it to get rid of that. Okay, and when we rationalize it, we have to complete the triplet. Okay, we need 3 of a kind. So we have 1, 2. We need another 2 2s. So we're going to multiply it by another 2 2s, so we have 3 of them altogether. With respect to the y's, we have 2 y's, which means we need another y to make 3 of them and get rid of that whole radical on the bottom. So we're going to multiply the top and the bottom by 2 squared y. Again, we're picking 2 squared y because when we look at this and this, now we have 3 2's. That's going to give us another 2 on the bottom. We have 3 y's here. That's going to give us a y outside that radical on the bottom. On the top, instead of writing it as 2 squared y, I just wrote it as 4 because 2 squared equals 4. And we're going to multiply things on the inside with other things on the inside, so we can multiply those together. So on the top, we have x cubed times the cube root of 20y. I just combine those two cube roots. And on the bottom, we have a 2 on the outside, and then we get another 2 from these 2's. I'm scribbling all over the place here. Okay, but another 2 comes outside, pairs with that 2, and we end up with a 4 on the bottom, along with that y that moves to the outside as well. Number 6, let's start off by just putting everything together. 2 times 3 is 6. 8 times 2, this will be on the inside, is 16. Add all those exponents, x to the 8th, y to the 4th. That's inside a 4th root. Break down that 16 into 4 2's. We have the 4th root of 2 to the 4th power, and we're looking for groups of 4 in x to the 8th, y to the 4th. Okay, which means when we do this, we're going to have 6 from the outside already, multiplied by that 2 that we moved to the outside from breaking down that 16. Okay, that's going to give us this 12. And then we have 2 groups of 4x's, 1 group of 4y's. Last 2 problems. In number 7, we're looking to subtract these 2 cube roots. So first thing is we want to simplify them as much as we can. So if we start with this 54 and we break it down, okay, I'm going to skip all the work. This is going to break down to a 2 times 3 times 3 times 3. If you did the factor tree, maybe you'd start with 9 times 6, okay, and then break each of those down. So I'm going to skip all that work from here on out. So we have a group of 3 3's. So the 3 is going to move to the outside with a 2 left over. Okay, we want to take out as many groups of 3x's as we can. It doesn't go in evenly, so we're going to have some left over. Same thing with the y's. Okay, we're going to do the same thing on the right side. We have a group of 3 2's and this 1 2 left over. And also as many groups of 3 that we can take out from x to the 4th and y squared. All right, so looking at that first one, okay, 3 comes to the outside. That gives us this. This 2 is left over on the inside. Okay, we have 3 groups of 3x's and x to the 10th with 1x left over on the inside. Okay, there's 1 group of 3y's and y to the 5th with 2 left over on the inside. Over here, okay, 2 comes to the outside. This 2 is still on the inside. 1 group of 3x's in here with 1 left over. Okay, and we can't take any groups of 3y's out of y squared, so that just stays there. So at this point, we can see that these 2 match exactly. All right, the parentheses here, I'm sorry, not the parentheses, the variables, so their exponents are both x cubed y, they also match. So these are like terms. We have 3x cubed y cube root 2xy squared minus 2x cubed y cube root of y squared, xy squared. So we're just going to subtract these coefficients. 3 minus 2 gives us 1 of this whole thing, which is the same in both of them. Subtract the coefficients and we get 1 x cubed y cube root of 2xy squared. This last one is just a rationalization problem. We did this back in chapter 4. We're not allowed to have this on the bottom, but we can't just multiply by a radical 7. So instead we have to multiply by the conjugate. We take whatever's on the bottom, we switch the sign to a minus, and then we FOIL it out. First, outside, inside, last. So on the bottom there, first terms, 4 times 4 is going to give us the 16. These 2 middle terms are always going to cross each other out. They're opposites. So these are gone. And then the last term, radical 7 times radical 7 is radical 49. This is just 7, and it's always going to be a minus sign because we have a positive times a negative. So on the bottom, we end up with 16 minus 7, no more radical signs. On the top, we're doing 5 times that conjugate there, and we end up with, this is our answer.